Motion in one dimension. This physics course will begin with the field of mechanics. Mechanics is the study of motion. We will start with kinematics and dynamics. Kinematics explains how things move, how fast they're traveling, if they're speeding up or slowing down, how long it takes to go certain distances, etc. Dynamics explains why things move, forces. We will study dynamics after kinematics. The first thing we will be measuring is distance. So what is it? What is distance? What is length? Try and define distance and length without using the words distance or length. As you can see from your efforts, it's practically impossible to define distance. Distance is a fundamental part of nature. It's so fundamental that it's impossible to define. Everyone knows what distance is, but no one can really say what it is. However, distances can be compared. We can compare the distance between two objects to the distance between two other objects. For convenience, we create standard distances so that we can easily make comparisons and tell someone else about them. We will be using the meter as our unit for measuring distance. Originally defined in 1791 as 1/10,000,000th of the distance between the equator and the North Pole as measured through Paris, the meter has been accepted as the universal standard measurement in science. The meter is the official unit of length in the International System of Units, or SI. However, you need to keep in mind that all units of distance are somewhat arbitrary. For example, the foot was a measurement that was literally based on the size of the human foot. However, humans have different sized feet. The length of a foot varied from 250 millimeters to 335 millimeters, depending on the country, city, even trade. It wasn't standardized until 1959, when it was determined to be exactly 0.3048 meters, which is a US male shoe size 14. The symbol or variable name for distance is little d, and the unit for distance is the meter, little m. Here we see a meter stick next to an average human adult. There are 100 centimeters in a meter, so we can write that two different ways. Scientific notation, we can say 1 centimeter equals 1 times 10 to the negative 2 meters. We can also use this conversion. So if you have centimeters and you need to put it into meters, which is something that we do often in this class, since we use meters as our standard measurement, not centimeters, just multiply by the conversion factor so that the centimeters cancel, leaving us with meters. So you can see that 1 centimeter is going to be equal to 0.01 meters. Let's zoom in on those first 10 centimeters, and you can see that there's 10 millimeters in each centimeter. Therefore, there are 1,000 millimeters in a meter. There are 1,000 meters in a kilometer. So 1 kilometer is approximately 0.62 miles, so more than half a mile, and that's how we convert between kilometers and miles. Similarly, everyone knows what time is, but try defining it. What is time? And remember, you can't use the word time or an equivalent to the word time in your definition. Like distance, time is a fundamental aspect of nature. It's so fundamental that it's impossible to define. Everyone knows what time is, but no one can really say what it is. However, like distances, times can be compared. We can say that in the time it took to run around the track, the second hand of my watch went around once, so my run took 60 seconds. When we compare the time between two events to the time between two other events, we are measuring time. This doesn't define time, but it allows us to work with it. The second is the standard unit of time. It was originally defined as 1/86,400th of a day. There are 24 hours in a day, 60 minutes in an hour, and 60 seconds in an hour. Therefore, 86,400 seconds in a day. The symbol for time is lowercase t. The unit for a second is lowercase s. So here, from here to here on this clock, would say t equals 10s, time equals 10 seconds. Speed is defined as the distance traveled divided by the time it took to travel that distance. Speed equals distance over time, or S equals d over t. Speed is not a fundamental aspect of nature. It is the ratio of two things that are. The units of speed can be determined by substituting the units for distance and time into the equation. Speed is distance over time. The units of distance are meters. The units of time are seconds, so therefore meters over seconds. And we read this as meters per second. In physics, you will need to find an unknown quantity based on given information, also known as givens. Here's a good approach. Identify and list the givens and the unknown. Draw and label a diagram of the situation. Select a formula containing the givens and the unknown. Cross out any terms that are equal to 0. Solve the formula so that the unknown is alone on the left. Substitute in the givens with their units and calculate the value of the unknown, including its units. A car travels 50 meters in 20 seconds. What is its speed? Here is a list of our givens, and we're going to use the speed formula. So we have our speed formula, we substitute in the givens with the units, and we get 2.5 meters per second. Be careful. The S here stands for speed. The S here stands for seconds. Don't confuse variable names with units. These are two different S's. A ball rolled at a speed of 3 meters per second for 2.5 seconds. How far did it travel? Here is our list of givens. We have speed and time. We want distance, so we're going to choose this formula, which is the only formula we've learned so far, and solve it for d. So we're going to have to multiply both sides by t so that the t's cancel on this side, and we get an equation, distance equals speed times time. Now we substitute in the givens with their units. You see the seconds cancel, leaving us with 7.5 meters. You can use the units to verify that you solved the problem correctly. Make sure to plug in your givens with their units and then simplify the units. Above, you can see that the seconds cancel out since this is in the denominator and that's in the numerator, leaving behind meters. And yes, the unit of distance is meters. Great job. This technique will be very useful when problems get more difficult.